Welcome to Study Loop.
So here in this question, to calculate the acceleration of the car, we can use the equation for acceleration. We can use the equation for acceleration, which is represented by A, and that is equals to the change in velocity upon the time t, and the change in velocity can be calculated as the final velocity minus the initial velocity upon time t. Here, Vf is the final velocity and Vi is the initial velocity. The final velocity is equal to the distance traveled divided by the final velocity is equals to the distance traveled divided by the time it took to travel the distance, and therefore the final velocity is 402 meters upon 6.40 seconds, and that is 62.5 meter per second. The initial velocity is zero because the car is starting from a standstill. So the initial velocity is zero because car was at rest before starting. Now, therefore, the acceleration A and therefore the acceleration A can be calculated as the final velocity, that is 62.5 meter per second, minus the initial velocity, that is 0 meter per second, upon the time, that is 6.40 seconds, and this comes out to be 9.77 meter per second square. Now, to calculate the number of G's the driver experienced, we can divide the acceleration of the car by the acceleration due to gravity. So the G force can be calculated as the acceleration upon the acceleration due to gravity, and that is 9.77 meter per second square upon acceleration due to gravity, that is 9.8 meter per second square. So the G force driver will be experiencing would be around 1 G. Now, to calculate the horizontal force the road must exert on the tires, we can use the equation. The force F is equals to mass into the acceleration. Here, mass is the mass of the car, and the mass of the driver and car is 535 kg, 535 kg into the acceleration, that is 9.77 meter per second square, and this comes out to be 5208 Newton, and therefore the driver experiences 1 G, and the road must exert a horizontal force of 5208 Newton. So I hope this answered your question. Thank you.